Welcome back, class. Today we're going to be talking a little bit more about cones. Our goal today is to be able to compute both the lateral area and surface area of the cone, much like we've done with cylinders, prisms, and pyramids. I also want to use it as an opportunity to compare the surface area of the cone to the surface area of the pyramids that we did in a previous week. Now, a cone, the net of a cone is actually a little bit unusual. So I have a quick video here to show you what the net of a cone looks like and how some of these different pieces are related to each other. As you can kind of look, you can see that the radius, when we're referring to a cone, we refer to the radius as the radius of the circular base. And as we can see, as that radius gets larger, it is going to change, of course, the shape of that cone. The height refers to that perpendicular height from the vertex of the cone that is perpendicular to that circle at the base. But it's really this net that I want to talk about. When we look at this net, pay attention to, in our diagram here, pay attention to this slant height. As we look at this net and we start to unfold it, we can see that the circular base is obviously going to be one piece of the net. But then when we take the cone shape and we spread it apart, notice that that slant height, which is going down all the different edges of the cone, is going to open up. And now that slant height becomes almost the radius of this sector. When we talk about the net of a cone, we're looking at the circular base that we see in orange, and then this blue piece is really the sector of a circle, or in other words, the part of a circle. Also notice that the edge of the sector, so the circumference, I guess, kind of that sector is actually going to be the circumference of that circular base. Now, if we go back into some of our formulas here, now that we've got an idea of what that cone looks like, in order to see where the formula comes from, I wanted to review how do we find surface area of pyramids. So I gave you an example of a pyramid here. This pyramid is a square pyramid. We can tell based on the base being a square. And if the base is a square, when we're finding surface area, we start with finding the area of the base. Square would be 3 times 3, so the area of this base would be 9. Now, to find the lateral area of a pyramid, we can do a couple of things. One method was a formula. The formula we learned was 1/2 the perimeter times the slant height. And we did take some time to kind of review that we use L for slant height rather than H for height. So if we go back and use this formula, the perimeter of our square of our base is going to be 3 times 4 sides that are 3 each. We'll be multiplying by 1/2, and our slant height, which is given, is 5 feet. So if we multiply 3 times 4, 12, half of 12 is 6, and 6 times 5 is 30. Our lateral area is 30, the area of our base is 9, and the total surface area is 39 feet squared. Now, the other option for finding the surface area would be to break it up into pieces, to find the area of the base first, and once again, that would be 3 by 3 or 9. Then we would have to find the area of the triangles, and we'd have to know that there are 4 triangles, and as long as the base is equilateral, all 4 triangles will be the same. What do we know about these triangles? We know that the height of the triangle is 5. We know that the base of the triangle is 3. Here was that base, and here was that height. And we know that to find the area of a triangle, we do 1/2 base times height. So if we do 1/2 times 3 times 5, that gives us 7.5. Now, since there are 4 triangles, when we multiply that by 4, we get 30. Once again, we still have a surface area of 30 plus 9. We still have a surface area of 39 feet squared. So we did look at 2 different methods. What I want to focus on, though, is this formula. We can use this formula to help us find the surface area of a cone as well. Now, keep in mind, a cone is going to have a circular base. So if we use this same formula for surface area of the one base plus the lateral area, Because the base of a cone is a circle, we will have to start with the formula pi r squared, since that's the area of a circle. Now let's talk about lateral area. Lateral area, using the same formula from above, is 1/2 the perimeter times the slant height. But in a cone, the perimeter would actually become the circumference, and the circumference of a circle is 2 pi r. So if we were to take this formula, and we're going to multiply the 1/2 times the 2 pi r times the slant height. So 1/2 times 2 pi r times slant height. By doing a little simplifying, 1/2 times 2 becomes 1. We're left with a lateral area of pi r L. Keep in mind, L stands for slant height, not height. And then, of course, if I want the surface area, I would have to add that to the area of the base, pi r squared, and we would end up with this formula for the surface area of a cone. If I only wanted the lateral area of the cone, that would be the formula pi r L to get the lateral area. So I wanted you to see where these formulas come from. Each formula is still based on this main idea of surface area being the area of the base plus the lateral area. But how we found the area of the base and how we find the lateral area, that changes based on what type of three-dimensional object it is. So a couple of quick examples. If I wanted to find the surface area and lateral area of the cone, I'm going to start with lateral area. To find the lateral area, I will do pi times the radius times the slant height. And in this problem, I am given a radius of 4. I'm given a slant height of 12, which means the lateral area is 48 pi. Now keep in mind that area is, we multiplied 4 inches times 12 inches. So again, this is going to be inches squared for our lateral area. For surface area, we will do the area of the base plus the lateral area. The area of the base is pi r squared, since it's a circle, and since the radius is 4, the area of the base is 16 pi. When we add to that the lateral area from above, we end up with 16 pi plus 48 pi, and 16 plus 48 is, I believe, 64 pi inches squared. So applying these formulas can be quick, but again, we want to know where those formulas come from. As we look at some different problems, pay attention to what information you've been given. In this next problem, we are told that the diameter of the base is 10 centimeters. If the diameter is 10 centimeters, then that means the radius is half of that, or 5. We're also given the slant height is 7 centimeters, so we know the slant height is 7 centimeters. To find the lateral area, we need pi times radius times slant height, which means we're going to be using that radius of 5 and that slant height of 7. 5 times 7 is 35 pi, and area will always be in squared units. For surface area, we'll do the area of the base plus the lateral area, and the base is a circle, pi r squared. Once again, we want to use that radius, not the diameter, so we're going to be plugging in 5, which gives us an area of the base of 25 pi. If we add that to that lateral area of 35 pi, 25 plus 35 is 60 pi. And once again, area is centimeters squared. Okay, in this example, again, pay attention to what we've been given. A plastic cone-shaped package is 10 inches in diameter. So again, if the diameter is 10, then the radius that we'll be using is 5. We're also given that the height is 12 inches. Okay, notice that it does not say slant height. This is specifically the height. So I would recommend that we start with making a sketch of the pyramid and labeling the dimensions. Pyramids have a circular base. We know that that diameter of that base is 10 inches, and therefore we know that the radius of that base is 5 inches. They also tell us that the height of the pyramid is 12 inches. Now, in order to find the the lateral area first, we're going to need to know the radius and the slant height. We already have the radius, we don't have the slant height. So we need to figure out what is this L, this slant height. And if we look at the triangle that we formed in here, we're going to have a right triangle, which means we can use our Pythagorean theorem. The legs of our triangle are 12 and 5, so 5 squared plus 12 squared will give us the slant height squared. That's 25 plus 144, that's 169 equals slant height squared. And when I take the square root, my slant height is 13. So once I know the slant height, now I can go back and find my lateral area. Pi times the radius times the slant height, and 5 times 13 is 65, so my lateral area is 65 pi inches squared. For the total surface area, I will need to add the base to that lateral area. So pi r squared, once again, use the radius of 5, which gives us a base of 25 pi, plus my lateral area of 65 pi for a total surface area of 90 pi inches squared. Last example is going to be very much a multi-step problem, and one of the things I want you to focus on here is how we're going to break this down, how we're going to decide which steps to do first, second, and third, and then I want us to practice actually writing up a description of those steps. So we are going to be describing a step-by-step method that would allow us to find ultimately the height of a cone if we know the lateral area and the base area. And then we're going to use this method to actually find the height of a right cone whose lateral area is 136 feet squared and whose base area is 64 feet squared. So let's start with formulas for the pieces of information we know. We know that lateral area is pi times the radius times the slant height. We also know that the area of the base is pi r squared since the base is a circle. So if we plug in what we're given, we know the lateral area is 136 pi, and we can plug that into this equation. We know that the area of the base is 64 pi, and we can plug that into this equation. Now in both equations, you'll notice that we have pi on both sides. And if I divide both sides by pi, then those are going to go away in both equations. That leaves us with an equation that says 136 equals radius times slant height. And for my second equation, I have 64 equals r squared. Of these two equations, the only equation we can solve at this point is this one, because this equation only has one variable left in the equation. If your equation still has two variables in it, we're not going to be able to solve this one yet. So we're going to come back over here, step 1, and I'm going to number this as our first step. Step 1 is that we're going to solve this equation. And we can solve by taking the square root of both sides, and we're going to end up with a radius of 8. So step 1 is we found the radius. Now once we know the radius, step 2 would be to take this radius, plug it into this equation over here. So step 2 will now be solving this equation. If I know that the radius is 8, I can now solve for the slant height by dividing both sides by 8. And the slant height, when I divide by 8, is 17. So now I have the slant height. Now the problem is asking us in this case to actually find the height of the right triangle. So step 3, let's draw a picture of what we have. I'm sorry, this is a cone. So we have this cone. We know that the radius of this cone is 8, and we know that the slant height of this cone is 17. Our task here was to find the actual height of the cone. So our third step would be setting up this right triangle. And in this right triangle, we can use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for the height. Now notice that the height is one of our legs, the 8 is another leg, and the 17 is the hypotenuse. So be careful that you're using your formula correctly. 17 squared is 289. When we subtract 64, we get 225. And when I take the square root, h will be 15. So our final solution is that the height is 15 feet. Okay? Now that we've kind of come up with a method, I want to talk about how we would describe in words kind of what we just did here. So if we were to go back and actually write this out step by step, okay, think about what our first step was. Our first step was to write the formula for area of the base and solve for the radius in this formula. Okay, remember when you're describing your steps, make sure you're describing which formula you're using, what are you solving for in this formula, okay? Step 2, we then wrote the formula for lateral area and substituted in both the lateral area and the radius. If you're using a formula where you're substituting in multiple values, make sure you explain which values you're substituting in. Using this formula, we then solve for the, miswriting here, solve for the slant height. And then what was step 3? Step 3 was we drew and labeled a diagram by labeling the radius and slant height. Then we used a right triangle and the Pythagorean theorem to solve for the height. Okay, when we're explaining this Pythagorean theorem, we should also mention which values we used where. The radius was one leg of the triangle, and the slant height was the hypotenuse. So a process like this, with step-by-step what we did, along with the work that demonstrates those steps, this is a great way to show that you clearly understand what the process is, and that we can put multiple steps together. So in one of your assignments, you're going to be doing a problem similar to this, where I'm going to ask you to show the work, but also describe a step-by-step method of how you approach